welcome to VentiTech Solar. In this installment, we're going to talk about a question that more people are asking nowadays. Whether it is because you already have an electric vehicle, because you're thinking about getting one, or because you have solar and you're thinking about an electric vehicle. And the question is, how much solar do I need in order to charge my electric vehicle? Now, another way to pose this question is, how many solar panels do I need in order to charge my electric vehicle? But the problem with panels is that it depends on what size of panel you're talking about, what wattage. Because if you're using 200 watt panels, then it may be only 10 panels. But if you're using 400 watt panels, it may be 5 panels, or it can be half. The number of panels you can determine easily once you have the solar array that you need, and then you divide that total amount of energy times the wattage of the panel you're talking about, that you're thinking about, and that will tell you how many panels you need. And we're going to answer that question using 3 different vehicles. I chose this because it's a small, medium, and large range. You can adapt this formula and this information to any vehicle, any size battery, any location, any commute. So we're going to start with the Tesla Model 3 rear-wheel drive. Is the number 2 electric vehicle sold in America in 2022, and is probably the smallest of the vehicle. It's not the most economical, but it's a small one that is very popular in America. In the high end, we're going to use the Ford F-150 Lightning, which it may not be in the top 10 electric vehicles sold in America, but it's fastly approaching, and also its counterpart, the Ford F-150 internal combustion engine, is the number 1 vehicle sold in America of any kind. SUV, light truck, passenger vehicle, any vehicle at all. So for that reason, it's a good benchmark. Okay, and in between those two, we're gonna have the number 1 electric vehicle sold in America in 2022, which is the Tesla Model Y. So between these 3 vehicles, which has different range, different battery sizes, size and weight, we can gauge how much energy, solar energy, is going to be used. So for this exercise, we're going to use an average of 15,000 miles driven every year, which translates to an about 41.09 miles per day if you divide that times 365. But in here, we're going to round it down to 41 miles of daily commute. All right. We are also going to use my location here in North Texas, which receives about 5 hours of useful energy from the sun. That's called the solar radiation or solar irradiance. There is a slight difference between those 2 words, but we're not going to get into that right now. Solar irradiance of 5 hours. If you go north, you may have to reduce that number to 4.5. If you go west of us, California, Arizona, that number increases to 6.5. So depending on the location you are, you may want to adjust that number. So those are the parameters we're going to use. We're going to use these 3 vehicles. We're going to use 41 miles of daily commute, and we're going to use 5 hours of useful sunlight. Another value we're going to need is the battery size. And for the Tesla Model 3 is 57.5 kilowatt hours. For the Tesla Model Y is 67.6. And for the Ford F-150 is 95.0 kilowatt hours. Significantly bigger battery, but it's also a significantly bigger vehicle, heavier, and it has an aerodynamic profile of a house or a refrigerator. So it's not aerodynamic at all. So moving on, the full charge range. For the Model 3 is 272 miles, for the Model Y is 279, and for the F-150 is 130. Again, you can tell that you can drive fewer miles for a bigger battery. That aligns because it's a bigger vehicle. To calculate miles per kilowatt hour, just like you calculate miles per gallon in the internal combustion engine, you divide the full range times the size of the battery. And in the case of the Model 3 is 4.73 miles, in the Model Y is 4.13 miles, and the F-150 is 2.42. So that's how much you're gonna drive per kilowatt hour, almost half of what the other vehicles are, comparing the Lightning to the Tesla vehicles. Daily commute, we set it up at 41 miles across the board. The next value that we're going to calculate is how much energy it requires to drive each one of these vehicles for that many miles of daily commute. And you do that dividing daily commute times the miles per kilowatt hour. In the Tesla Model 3 is 8.67 kilowatt. In the Tesla Model Y is 9.93. In the Lightning is 16.93 kilowatt hours. So it's gonna take 16.93 kilowatt hours to move the little tank that everybody use here in America. As far as solar radiation, we estimated 5 hours. Again, that's my location. You can adjust it to your location. And one more time, all these values are adjustable. If you are getting less miles on the Model 3 than 272 because your commute is all highway or you carry more weight, you can adjust that value to what your daily commute, what you can get out of your battery for your vehicle. Again, and if you have a bigger battery, again, this formula also works. Bigger batteries, different ranges, different commute, and different solar radiation. So the next value we're going to calculate is how much power per hour do I need? And you do that dividing daily energy use times how many hours of the day you can use the sun. And in the case of the Model 3 is 1.73 kilowatt, the Model Y is 1.99 kilowatt, and in the case of the Lightning is 3.39 kilowatt. Now, if you could use 100% of the energy that falls into your solar array, and that same energy will go into the battery of your car, then this will be the size of your solar array. So 1.73 for the Tesla and 3.39 for the Lightning. But there is a lot of inefficiency. There is a lot of power losses going from the solar panels straight into the batteries. So you have to convert from DC, from the solar panels, to AC, and then another conversion from AC into the battery of the car, which is DC. We also have to factor the solar alignment and tilt. So to produce this much energy, a solar panel will have to be aligned perfectly to south, and it will have to have a tilt angle equal to your latitude north in the northern hemisphere. So nobody will have that perfect scenario unless you have a ground-mounted system. If you have a ground-mounted system, you can perfectly align it south and you can tilt it to exact angle for maximum production in your location. Because of that, we're gonna add a 20% inefficiency on the whole equation by multiplying the net power times 1.2. And for that, we get in the Model 3 a 2.08 kilowatt system. That's the size of the array. In the Model Y is 2.38, and in the Lightning it would be a 4.06 kilowatt system. Let's put it in perspective. If you have an 8 kilowatt system in your home and you bought a Ford F-150 Lightning and you drive 41 miles a day in your location where you get 5 hours of solar radiation, you probably will use half of your solar system just charging that vehicle. Now, if you drive more, it will take more. If you drive less, it will take less, and you get the idea. But basically, this is the size of the system for this vehicle, given the daily commute, given the solar radiation, and given the size of the batteries and the range. Now, if you want to calculate this same value for any other vehicle, I'm giving you the formula here, which I'm not going to attempt to read it, but that formula will work for any vehicle, any range. Now, from all these values, probably the one that is more difficult to find is going to be the solar radiation for your location. And for that, I'm going to give you this map, the continental US, courtesy of the National Renewable Energy Laboratory. It's a government agency that collects research and data from universities and industry alike that put out really good information, and they collected. It's a database that you can use. It's free to use. In this map, I marked Dallas as my location, North Texas. You can see that the color in the surrounding area of Dallas matches to the table on the upper right to 5 to 5.5 kilowatt hours per square meter per day. That's what that table, that's the reference that you see on the top right. If you go west, then the color gets darker, so it matches to 6 to 6.5. If you go north or northeast, the color matches to 3 or 3.5. So there you have it. if you have any other vehicle, any other questions, just give us a call, drop us a comment, email, and we will answer. We'll get to you as soon as we can. Thank you for watching.